Hello, maths lovers. Welcome back to Turtle Maths, your go-to channel for all things mathematical. Today, we have a fascinating topic on our plate, the distance formula. Whether you are a student looking to ace your math exams or just someone who is curious about the beauty of mathematics, you are in for a treat. So grab your notebooks and pencils because we are about to dive into the world of distances in 2 and 3 dimensions. So let's try to understand what distance formula is. So to kick things off, let's just start with the basics. The distance formula helps us to find the distance between 2 points in a coordinate plane. Today we are taking an example, and in this example I have taken the point 1, 2 and 5, 6. And let's say I would like to find out the distance between these 2 points. So I'm interested in finding the distance between, let's call this point as A, let's call this point B, the distance between these 2 points. So the distance formula says the distance between point AB will be given as the square root of x2 minus x1 square plus y2 minus y1 square. So let's call this 5 6 as x2 y2, and the point 1 2, let's assume that they are my x1 and y1. So in order to plug in this or substitute the values of x1, y1 and y1, let's do it. So we will start with x2. We have got 5 minus 1 whole square plus 6 minus 2 whole square, and we will have 4 square plus 4 square, which is 16 plus 16, that will come out to be root 32. Root 32 can be written as 4 root 2. So that's unit square or unit, that's the distance between point A and B. That's how you use it. Let's see how we can derive this formula. So for any point, for example, here I have got, let's say, x1, y1, and I have got x2, y2. Let's try to implement certain things. I am interested in, let's call this A, this is my B. I'm going to drop a perpendicular from these 2 points, and let's say their perpendiculars meets at C. So what should be the distance of this C? Look here, from the x-axis to the point B, it's y2, and from the x-axis to the point C, it's y1. So I can say that length of BC can be given as y2 minus y1. Similarly, if I am interested in finding the length of AC from the origin to the point C, this length is x2. You can see it's x2. And from origin to point A, it's x1. So in order to find this distance, we can write it as x2 minus x1. Now pay attention, this is a right angle triangle, and if it is a right angle triangle, I can apply the Pythagorean theorem, which says that the square of the hypotenuse, in this case which is AB, the square of the hypotenuse should be equal to the sum of the square of other two sides. So BC square plus AC square. And that's what I have done. If I want to find the length of hypotenuse AB, I can take the square root of the sum of the other two, the square of the other two sides, the sum of the square of other two sides. So AB is equal to BC square plus AC square's square root. And if I plug in the value of BC and AC, see what we will get. Y2 minus Y1 whole square plus X2 minus X1 whole square under the square root sign, and that's what my distance formula is. So that's the derivation of distance formula. Now, if I believe you have understood this part, that how I got the length of BC and AC and how I have used Pythagorean theorem in order to derive the distance formula. If you have understood this, let's try finding the distance between 2 points whose coordinates are given to you. We have discussed one example and also derived the distance formula. Now I want you to attempt a problem. Let's assume that we are given with a coordinates of 2 points and we are asked to calculate the distance between them. So in this case, our point A is given by 1, 3 and point B is given by 3 minus 7, and your task is to find the distance between AB. So find the distance between point A and B, or in other words, calculate the length of AB. You can pause this video to attempt this problem by yourself. All right, so you have attempted this question. Let's see what the answer is. Now, in order to find the distance between AB, I can use the distance formula, which says AB should be equal to x2 minus x1 whole square plus y2 minus y1's whole square. So let's say my point A, so the coordinates are x1 and y1, and point B, the coordinates are x2, y2. You can interchange them. That won't make any difference. I like to do this so that when I am substituting the coordinates values back in the formula, I can refer back and I can do it quickly without making any mistake. So here we have got a square root. So x2, which is 3, minus x1, which is 1, whole square, plus y2, which is negative 7, and negative y1. So y1 is 3 and negative of 3 is negative 3 whole square. Let's see what it is. We have got 2 square plus, here we have negative 10 whole square. One of the most common mistake that I have seen a lot of students doing it, when they are plugging in these values in their calculators, they end up writing negative 10 square, and if you will do that, what your calculator does, it gives you an answer of negative 100. Now, there is a problem, because when you are adding this negative and then you're writing 10 square, the calculator first calculates the square and then multiplies the answer with negative sign. If you have a negative number and you would like to find its square, so put a bracket. Put it inside a bracket, write negative 10 whole square, and the answer should be 100. Think about it. A negative number multiplied by another negative number, the answer should be positive. So moving ahead, be careful when you're plugging these values in your calculator. Always use brackets. We have got 4 and here we have got 100, and a square root of 104, which comes out to be 10.198 unit. If you would like to write it in two decimal places, so the answer would be 10.20 unit. Now let's move ahead. In 3D space, we have three coordinates, x, y, and z. Don't worry, the distance formula still works its magic. But now we have one more coordinate to consider. It's like adding an extra dimension to your mathematical toolkit. And there you have it, folks. So if I have got my point, let's call this point A, and this time A has got three coordinates or three dimensions, x1, y1, z1, and here we will have B, which is x2, y2, and z2. So the length between AB will be given as the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We can derive this by using Pythagorean theorem in three dimensions. Now, since you have understood distance formula in 2 dimension and 3 dimension, let's take an example of applying distance formula in 3 dimensions. So here we are. Let's say the coordinates are P, which is P and Q. So the coordinate P is 2, 1, and 4, and coordinate Q is 4, 11, and minus 5. And we have to find the length of PQ. So PQ can be given as the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We can assume, let's call the coordinates of P are x1, y1, z1, and coordinate of Q are x2, y2, and z2. Let's substitute these values back in the formula. So 4 minus 2 whole square plus 11 minus 1 whole square plus negative 5 negative 4 whole square here we have 2 whole square 10 whole square and negative 9 whole square. Let's calculate their square. 4 plus 100 and negative 9 square would be positive 81, and the result is 185. Square root of 185, this will come out to be 13.601 unit. Now I want you to attempt this problem by yourself. You can pause the video. You have to find the distance between points R and S. Here we will use the distance formula for 3D points. The answer is the length of RS is 8.37 units. If you have got this, your answer is correct. If you haven't, try attempting it once more. Mathematics is a fascinating world full of wonders, and I hope today's journey has left you feeling inspired. If you enjoyed this video, don't forget to hit that like button and subscribe for more exciting math content. And as always, keep exploring, keep learning, and keep loving maths. Until next time, this is Turtle Maths signing off. If you have any questions or topics you'd like us to consider in future videos, leave them in comments below. Stay curious.